Hello friends and family. Um, I've edited together the presentation film that I did for my final design project as part of my Masters in Architecture. And I'm going to record a little voiceover, so like as if I was presenting to you. So hopefully you can kind of see what I've been up to this year and maybe give you kind of an idea of what I've been doing when I've been working away at the studio. So yeah, I hope it makes sense. If you're confused, send me any follow-up questions. But I hope you enjoy it, and I hope it at least interests you. So as you just heard in my introduction, this is William Tindall's 5th year design work, presenting work on my project entitled Learning to Draw Again. The project began from a personal interest in hand drawing as a spatial practice. Last year I explored this through a drawing machine that moved paper around my head. That work opened up a question that has stayed with this project. How can drawing produce space before it is fixed as geometry? A drawing can hold uncertainty in a very precise way. A mark can imply depth, edge, surface or atmosphere, or remaining open to interpretation. Its value lies in the suspended condition, where spatial relations are suggested before they become modelled. Alongside this, I became interested in point clouds as a digital format through which space is recorded and reconstructed. Point clouds typically belong to scanning and measurement, and translate existing environments into spatial data. The project emerged from the tension between these two forms of spatial production, the ambiguity of hand drawing and the apparent precision of point clouds. The research focus for the year was deliberately simple: how to draw a point cloud. 1. Sharpening the pencil. The early work tested scanning, Gaussian splats, photogrammetry, and AI interpolation. These tests are documented in the appendix, and their value was clarifying the problem. The drawing could not remain a surface effect added to an existing digital model. It had to become the source of depth itself. 2. Making the first mark. The first working route came through monocular depth estimation, a machine vision process that predicts depth from a single image. It does not measure space directly. It reads visual cues such as contrast, edge, texture, shadow, and scale, then estimates relative depth across the image. I use Midas to produce a dense depth map from a hand drawing. The model is usually applied to photographs, so the drawing enters a system trained on a different visual world. Its marks are treated as spatial evidence, allowing graphite, tone, pressure, and gradient to be interpreted as depth. The script then rebuilds that depth map as a colored point cloud. Each pixel is given an X and a Y position, while the predicted depth value becomes its height. Additional controls flatten the paper, strengthen the drawn marks, and tune the relationship between tonal density, edge, color, and spatial relief. The output is a designed translation rather than a measured scan. A hand drawing becomes a navigable spatial field, where marks begin to behave as ground, surface, atmosphere, and fragment. This is the point at which drawing starts to produce architectural material. Live drawing. Seeing, shifting, sculpting. Once the drawing could be processed quickly enough, the workflow became a live apparatus. The drawing was produced in relation to the point cloud as it appeared. This introduced a feedback loop between hand and machine. The hand produced the drawing produced a cloud, and the cloud began to act on the hand. Marks were darkened, extended, erased, layered, or softened according to the way that they appeared as depth, surface, edge, density, or atmosphere. The desk became the site of this exchange. Paper, pencil, camera, depth estimation, script, and point cloud operating together. Two forms of looking guided the process. The rotating view tested the cloud as a spatial object, while the high-quality static view allowed a slower judgment of ground, enclosure, texture, collapse, and spatial legibility. Drawing therefore became a live design method. Each mark was evaluated twice, first as a mark on paper, then as a spatial behavior inside the generated cloud. The drawing became something adjusted through the system's response, as the hand learned which gestures could produce lift, blur, edge, void, surface, or fragment. Latent elements. The live system made it possible to study the cloud as a field of recurring behaviors. I began by calibrating the relationship between drawing and depth, base height, stroke weight, edge intensity, fill strength, and smoothing. Small adjustments produce very different spatial characters, from flat graphic fields to dense atmospheric terrains. These tests led to a series of drawing modes: balanced, unresolved, wash, and detail. Each mode changed the way the same drawing input was read. Wash privileged tonal field and soft ground. Edge amplified line, contour, and boundary. The purpose was to establish a drawing grammar for the system, rather than rely on a single default translation. Opacity and absence extended this grammar. Transparent inputs showed that the system responded to withheld drawing as well as visible marks. Gaps, masks, and empty regions began to produce suspended or interstitial conditions between surfaces. Projective views pushed the process further. Views taken from inside the point cloud were flattened and returned to the system as new inputs. These images began to read as strange landscapes, partial horizons, broken grounds, veils, screens, and spaces seen from within rather than above. The cloud became source material for its own continuation, output, drawing, and input folding into a recursive sequence. The pause, analyze, and freeze tools turned the live field into something that could be held and worked on. Selected moments were stopped long enough to be read, cut, and developed. Ground, edge, rib, surface, screen, fog, and fold can begin to appear as latent elements within the system. The fold mechanism allows the drawing to issue a direct spatial instruction. Orange lines are read as hinged lines in the live cloud. A mark can cut into the field, establish an axis, and alter the orientation of the surface around it. Latent architecture. Before the final extraction work, I tested several ways of making the cloud behave architecturally. These are framed through this diagram, discussing the relationship between program and architectural legibility as I was designing and working. Projected architectures. Developing from pause, analyze, and freeze, projection made the field more operable. Mathematical cluster analysis, subsequent classification to different clusters of points, enabled the insertion of fragments of geometry. These planes, splines, clusters, and frozen regions became ways of testing where density, edge, and continuity could support architectural material. The cloud was no longer only a spatial atmosphere, it became a field to be read and worked into, defining rules to place geometry within it. Terrace grounds. The terrace tests translated height variation in the cloud into stepped fields. The script identified coherent regions of vertical change, simplified them into terrace bands, and converted them into printable lattice plates, with perimeter frames and column supports. The cloud began to behave as a porous structural landscape. Drawn structures. Stroke structures, contour edges, crossings, and line families were extracted and lifted into 3 dimensions as tubes, ribs, ribbons, suspended traces, and support networks. Line began to organize span, enclosure, layering, and depth. Extracting from the drawing. Extraction is where the live drawing system becomes a method for making architecture. The drawn cloud is meshed in Cloud Compare, edited through scalar fields, selected and repaired in Rhino, and then prepared for 3D printing. Each step is a judgment about what can be retained from the cloud. The final models come from this chain: drawing, depth, point cloud, fragment, print, site. Where to begin? Again. The site enters the project as a new drawing surface. After developing the workflow, the question became where the process should begin again, architecturally. I treated the site as another piece of paper, a ground already marked by routes, edges, buildings, and vegetation and infrastructure. The first site drawing became the input for the next sequence. It was not a survey drawing in the conventional sense. It was a way of translating the site into the visual language of the system, lines, density, shadows, and absences, that could be read again through machine vision. Each drawing generates a point cloud. Each point cloud is meshed. Each mesh produces a new view from inside the generated space. That view returns to the desk as the next drawing. The sequence builds through repetition, with each pass carrying traces of the previous one, while introducing a new reading of the site. Over time, the drawings produce a register of geometry, surfaces, ridges, voids, and fragments gathered from the site and reworked through the machine. This register becomes the material archive for the architecture. The models are drawn from this accumulation, using the meshes as a bank of spatial conditions that can be selected, scaled, fabricated, and placed back into the site. Paper architecture. The final sequence gathers the white models as paper architectures: landscape, institution, room, detail, fabrication, and body. Referencing Shumi's Parc de la Villette, program is distributed as a field of events. Each model tests how cloud-drawn material becomes architecture: ground, enclosure, threshold, construction, and touch. At 1 to 750, the model works as an evolving landscape sheet. It is designed to accept new printed fragments as the drawing process continues, so the site can be recomposed over time rather than fixed as a final master plan. As new drawings are added, new ground conditions, routes, edges, and planted areas can be printed and added to the model. At 1 to 200, the project begins to test larger architectural insertions. Floor slabs, platforms, and building fragments are printed separately and placed into the landscape model, allowing the institutional program to develop as the site changes. The model becomes a working field where university spaces, workshops, public rooms, and landscape fragments can be rearranged, extended, and tested. At 1 to 100, the model treats the landscape as an open ground for printed editions. As the drawing sequence develops, new fragments are inserted into the terrain, forming paths, terraces, shelters, edges, and planted pockets. The bike shop anchors this field with a public program, allowing suggestive spaces to gather within the evolving landscape. At 1 to 50, the drawing studio tests the first complete enclosure. The drawn ground is occupied rather than viewed from above, forming a room around drawing, display, and observation. The model asks how the landscape fragments can become interior space, a place where surface, wall, floor, and threshold are held within one continuous paper-derived form. At 125, the ice cream stand tests a range of smaller public spaces within the drawn fragments. Referencing Christian Kerres' incidental space, the model explores how complex printed forms can produce ambiguous, suggestive interiors. Counters, openings, and canopies, and pockets of shelter appear within the same fragmentary landscape, giving the drawing a more social scale of occupation. At 1 to 10, the wall and floor detail focuses on enclosure, thickness, and inhabitation. The model isolates one architectural edge, showing how the drawn geometry becomes wall, ground, opening, and seat. It tests how a fragment can be occupied directly, sat on, leaned against, looked through, and used as part of the building. At 1 to 5, the roof edge detail moves into fabrication. The model tests how a fragment of the drawing could be cast, fixed, and assembled, rather than remaining only a printed surface. The drawn geometry is treated as a material component, with edges, thickness, joints, and mold logic beginning to discipline the form. At 1 to 1, the handrail brings the project to direct contact. The scale shifts from enclosure to touch, asking how a line extracted from the drawing can meet the hand, closing the sequence with a fragment that is no longer looked at from a distance, but physically held. The handrail is the final model, but the process remains open. The project is still a drawing system: paper, hand, camera, machine reading, cloud, model, and return. That's the end of the presentation. These are then some nice images I just had playing in the end, where I took photos of the models and put them back through the system. It's kind of like a little ha-ha. It's completely recursive. So thank you for watching. I hope it was enjoyable. Thank you for your support throughout this process. And looking forward to the next chapter.